Hello, my esteemed viewers. We'll be looking at projectile motion in this particular lecture. So on your screen, you can see the definition of a projectile motion. When we say projectile motion, what is this motion we're talking about? It's actually a motion that involves projecting an object into the air at a certain angle to the horizontal, or maybe projecting an object horizontally from the height of a building or from a particular height to the ground. This object that is being projected is called a projectile. Ordinarily, the path followed by a projectile is actually a parabolic path, as you can find out from the figure, from this particular figure here. This is the path followed by the projectile. It's parabolic in nature. And one very good feature of a projectile motion is that the projectile itself undergoes two separate motions simultaneously. When we say simultaneously, we imply that both motions are occurring at the same time. Like I said, when we talk about simultaneous motion, we imply that both motions are occurring at the same time without the direct contribution of the other. That is, we have two kinds of motion that occurred at the same time, the vertical motion and the horizontal motion. If you see from the diagram, let's assume an object is somewhere here at this point O. When you project the object at an angle theta to the horizontal, the object follows this direction. This is the curved path, parabolic path. Now, as the object is going up towards this direction, it is undergoing a vertical motion, and at the same time is undergoing a horizontal motion. So both motions, they are occurring at the same time, but they are independent of each other. In the horizontal direction, which is this direction, the object moves at a constant speed. And at the same time, like I said, is undergoing a vertical motion. A footballer who tries to play a free kick, let's say from a point, plays the free kick from the ground up to the air, is exhibiting projectile motion. In that case, the ball, which is undergoing that motion, is the projectile. The path that is followed by a projectile is what we refer to as a trajectory. So if you look at this parabolic path, this path is the trajectory. The trajectory. Now, consider a ball that undergoes a projectile motion from point A. Let's say this is point A, and this is point B. The object undergoes a projectile motion from this point and lands at this point B. You can get the maximum height attained by the object. You can get the horizontal distance covered by the object, which happens to be the horizontal range. Or we can talk about the time it takes the object to attain maximum height. That is the time it takes the object to move from point A up to this point Y, and also the total time of flight. The total time of flight is the time taken for the object to move from this point A, that's the point of projection, to where it touches the ground again, that is point B. Now, having said this, there are certain things we need to know or certain points we need to consider when we talk about a projectile motion. Initially, we've said that this object at this point is projected at an angle theta to the horizontal. So if that is the case, the object is neither, the velocity rather of the object is neither in the vertical direction nor in the horizontal direction. Rather, it's at an angle to the horizontal, which is between the vertical and the horizontal. So this makes this velocity u to have both a horizontal component and a vertical component. How do you solve for the horizontal component? How do you solve for the vertical component? This is the direction of the velocity. We can draw a small line here to make this a triangle. So if we bring that out, we have something like this, which is the direction of the velocity u. This is the horizontal direction. And of course, this is the vertical direction. So this represents the horizontal velocity, and this represents the vertical velocity. This is the angle theta. So to get the horizontal velocity, that's the component of this velocity in the horizontal direction and in the vertical direction, we make use of trigonometric ratios, where we can just say for the horizontal component, we can say, since we are looking at the adjacent side and the hypotenuse, we can say for the horizontal, we can say that cos theta is equal to this over this, so that u of x is equal to u cos theta. That's how this value came about, or this formula. For the horizontal, for the vertical direction, we say sine theta. Since we are concerned with the opposite and the hypotenuse, we use sine theta is equal to opposite, which is this, over hypotenuse, which is, so that this gives us the vertical component to be u sine theta. So when you come across a problem involving projectile, maybe you are given the velocity to the horizontal. Sorry, you are given the velocity of projection at an angle to the horizontal, and you are asked to find the vertical component of the velocity or the horizontal component of the velocity. If it's the horizontal component, this is the expected formula to apply. If it's the vertical component, this is the expected formula to apply. Now, in talking about a projectile motion, it don't just end with projecting an object from the ground. Okay? You also have a case where you project the object from a height. We'll look at that also. Then again, we talked about the total time of flight, the horizontal range, the maximum height, the time taken to attain maximum height. There are formulas to apply to effect these calculations. So the next slide is going to give us the formulas that we apply when we are talking about time of flight, time taken to attain maximum height, the horizontal range. So, for the time of flight, that's the time that it takes to attain maximum height. We are not going to derive that expression, just give the formula, but it can be derived. The time taken to attain maximum height That time can be expressed as t is equal to u sine theta over g. Then the total time of flight, that's the time it takes the object from the point of projection to the final point, is twice the time taken to attain maximum height. So total time of flight is twice the time it takes to attain maximum height. So t will be equal to 2u sine theta over g, or just say 2 times t. This is t. Then for maximum height, we can use this expression. Maximum height can be calculated from u squared sine squared theta over 2g, where g is acceleration due to gravity. Then the horizontal range we can use r is equal to u squared sine 2 theta over g. In the case where the range is maximum, theta is 45 degrees. So in that case, sine 2 theta will be equal to sine 90 degrees, which is equal to 1. So for maximum range, we have that r will be equal to u squared over g. Why? Because sine 2 theta is equivalent to 1. So everything here equates to 1. So maximum range is u squared over g. And so in the next slide, we are going to consider the case of an object that is projected from a height. Projection of an object from a height. And we'll look at the necessary equations that can be used to handle such scenario. Then we solve some problems, a few problems on projectile. So let's look at another case of projection or projectile where an object is projected from a height. This is a height, this is a diagram. Let's call this point P. Now, this object is projected horizontally with a horizontal velocity u. We use the subscript x to indicate it's in the horizontal direction. Now, this is the horizontal range, that is the distance from the foot of the building to where the object touches the ground again. Then this is the height of, let's just say building, but that h is the height. That is the distance from the ground level to the top. When you're solving problems involving projectile in this case, we can make use of these equations of motion. I have used plus in this particular equation. The reason is because I decide to choose the direction of gravity as positive. So moving in the direction of gravity, taking it as positive, we use this set of equations. Very balanced. So just rewrite the equations of motion to fit in g, where g is acceleration due to gravity, and fit in h, where h is the vertical height or vertical distance. T is the time it takes the object to move from this point P to this point. Let's call this one point Q. So this is point P. Always remember that this horizontal velocity is independent of the vertical motion. So when you're working on problems involving this, you have no need using initial horizontal velocity for vertical calculation. No, it's wrong. In terms of horizontal motion, if we are to find, let's say, the speed, the horizontal speed, we can use this normal formula. Speed is equal to distance over time, where speed is distance over time. If we are to find the distance, which is the horizontal range, we can use distance is equal to speed times time. Always take note that at this point of projection, the object is initially at rest. So at the top of the height, the vertical component of the initial velocity is always there. Because at that point, the object is at rest before it is projected horizontally. So the vertical component of this velocity, of the initial velocity, is 0 at the top. This point is very important in solving problems. So in the next slide, we are going to look at some few problems involving projectile, maybe 1 or 2 problems, then we wrap it up. So in this particular question, the first one, we have that a ball is kicked into the air by a footballer, the velocity of 20 meters per second, at an angle of 30 degrees to the horizontal. We'll stop. Calculate the following. We have the time taken to attain maximum height, total time of flight, maximum height attained, the horizontal range. We just simply apply the formula to solve these problems. We can give a sketch of the problem to maybe just to throw more light. So I can go like this. This is so in this particular problem, the initial velocity is 20 meters per second. The angle is 30 degrees. And g, of course, is given as 10 meters per second square. So therefore, we just simply apply the formulas one by one. For A, the time taken to attain maximum height is t is equal to u sine theta over g. U is simply 20 meters per second times sine 30 degrees all over 10. Sine 30 is 0.5. So this we go and we have 2. So 2 times 0.5 gives us 1 second. So the time taken to attain maximum height is just 1 second. Then for the total time of flight, if the time taken to attain maximum height is 1 second, then the total time of flight is 2 times t, or 2u sine theta over G, which gives us 2 times T. 2 times 1 is 2 seconds. Then for the maximum height, we express our formula, which is 4 beg your pardon. So we have U squared sine squared theta over 2G. U is 20. Sine squared theta is same thing as sine theta squared. So to solve this, we have 400 times 0.5 squared, because sine 30 is 0.5, all divided by 20. When simplified, this gives us 5 meters. So the maximum height is 5 meters. Then for D, the horizontal range. Horizontal range is expressed as U squared sine 2 theta over G. Our U is 20 meters per second. So when this is simplified further, we have the arrow is equal to 400 times sine 60 divided by 10. That eventually gives us 34.64 meters. The answer is given to 2 decimal places. So we're going to look at question 2, which borders on an object that is projected from a height. Object that is projected from a height. So the next slide will take care of that question. In this problem, we have that an object is projected horizontally from the top of a building whose height is 20 meters from the ground level. Calculate the time taken by the object to hit the ground. G is given as 10 meters per second square. Then the next question is, if the object hits the ground 10 meters away from the foot of the building, calculate the speed with which the object was projected. So we're going to look at these 2 questions carefully to help us not to make any mistake. We're going to illustrate the question with a diagram. So let's say this is the height. Then this is the horizontal direction. This is the top of the building. The object was projected horizontally. So this is the direction of the horizontal velocity. Of course, from projection, it will follow a curved path to strike the ground. This is the height of the building. which is 20 meters. So from this end, so the first question is that we should calculate the time taken by the object to strike the ground. The time can be calculated using either the vertical component or the horizontal component, because it is the same time that is required to cover both motion. So, if the distance between this point and this point is 10 meters, that's what the question tells us. $10. The best, we cannot use the horizontal value now because we have only the distance, horizontal distance. If we say speed equal distance over time, speed is equal to distance over time, then it implies that the time will be expressed as distance over speed. But we don't have the value for the horizontal speed, which we are to calculate. So what we do, we move to the vertical component and see if we can apply the vertical component to find the time. Since we are given g, acceleration due to gravity, we are given the height of the building, we can explore the formula involving height. So we say h is equal to u subscript y. The y indicates that we are talking about the initial vertical component of the velocity. Since this projected object is moving in the direction of gravity, we use the positive sign, so we say plus half gt squared. At this point, at maximum height, at this point, at the top of the building, at the height, the initial vertical component of the velocity is 0. So we are left with the equation h is equal to, since this is 0, everything here automatically becomes 0. So we have h is equal to half gt squared. If you rearrange, t will be equal to 2h over g, or square root. So our h is 20, so we say 2 times 20 all over 10 square root, which is 40 over 10. That gives us 4, square root of 4. So our time is 2 seconds. See how simple it is. So the time taken by the object to hit the ground from this point, from the top, is 2 seconds. So for the B part, if the object hits the ground 10 meters away from the foot of the building, this is the foot of the building, the object is hitting the ground 10 meters from the foot of the building. So it means the horizontal distance covered is 10 meters. So we should calculate the speed with which the object was projected. Remember, the object was projected horizontally. So the speed you are looking for in this particular problem is the horizontal speed. So what is that horizontal speed? What formula are we going to apply? We simply apply the formula involving horizontal motion. So we can say speed is equal to distance. That's the horizontal distance all over time. Remember, the same time it takes for the vertical motion is the same time it takes for the horizontal motion. So, our time in this case is 2 seconds. So we say 10 meters divided by 2 seconds. That leaves us with the horizontal speed to be 5 meters per second. So the horizontal speed is 5 meters per second. So we consider 2 problems in this topic. One is when the object is projected from a point, follows a parabolic path, projected from a point at a certain angle to the horizontal, where it follows a parabolic path to strike the ground again. The second case is when an object is projected from the top of a building. So those are the 2 major cases involving projectile. So on this note, I've come to the end of this particular lecture on projectile motion. Do remember to subscribe to my channel, like my page, drop your comments in the comment section to further improve our videos. Thank you.